Right, so go ahead and attempt to balance the first reaction. I'll work through it in a second. I'll put a poll up for you to put your answers in and vote on what the correct answer is. One vote. You guys are batting 100%. Congratulations. Keep score up here. J9 is on the board. Professor Melko, 17 is not correct. All right, take your time. That's what we're all here for. So let's walk through this first one together. So like we did in class, I sort of divide this up into the various species that we need to balance. The whole point is that the left side of the equation, the reactants, every element there has to be the same number of elements on the left as on the right. Okay, same number of strontiums on each side. We're not creating or destroying matter, right? That's impossible. So you must have the same number of strontiums on the left and the right. The pull box is indeed blocking the second problem. All right, hopefully that fixes it. Thanks. Still working on getting these pull boxes working, but I think it's a nice addition. A little more interactive. It's also probably blocking your scoreboard up there in the upper right, but that's okay. All right. We're not creating or destroying any matter, so there's got to be the same as strontiums on each side. So I like to write below the reaction like this: what species am I trying to balance? Okay, and you can divide up the reactants from the products, put a line there or something. Okay, on the left there's one strontium, on the right there's one strontium. On the left there's 2 hydrogens, on the right there's 4 hydrogens. 2 because there's 2 OH groups, and plus 2 from the elemental hydrogen, which is one of those diatomics. Okay, and there's 2 oxygens on the right, 1 on the left. So clearly the strontiums are fine. We are all winners, right? No losing in chemistry. Everybody wins. Knowledge is power. Right, so winning. So we need to up the hydrogens and the oxygens, obviously, on the left. So this one coefficient out in front of water, I'm just going to up to 2, right? Might as well increase it, see where that gets us. Now we have 4 hydrogens on the left and 2 oxygens. And now we're done. Okay, because now we're at 4 on each side for hydrogen, 2 on each side for oxygen, and 1 on each side for strontium. Okay, so yeah, the correct answer for the poll there was 1. Okay, we end up not having to change anything about strontium. Yep, so there's a 1, more or less a 1 implied in front of strontium, a 2 implied in front of water. All right, so let's move on to the next one. I'll make another poll, but get started balancing it. And here I'm going to balance the polyatomics as a whole group. Okay, because SO4 is on each side, I'm going to keep track of those SO4 units. Because OH occurs on both sides, I'm going to keep track of an OH as a unit. All right, so proceed with balancing this, and I'll put up another poll. I forgot last stream we figured out you guys wanted more cats. So find ways to develop more cats. Or cat ions, maybe. So you should be setting it up something like this. 2 potassiums on the left, 2 hydroxides on the left, 1 barium on the left, 1 sulfate on the left, and all ones to start on the right. All right, so clearly we need to up the potassiums. Still 0 votes in the poll. Right, I guess I'll stop awarding bonus points for poll participants. So that's up potassium. It needs to be 2. Yeah, these are the exact answers to the next exam. Not quite, but there's a chance these problems make it onto the exam. I won't make the next exam for a while, so I'll forget what was even in this video, so there's a 50-50 chance. All right, let's up potassium on the right. We need to get it to 2, so we'll add a 2 coefficient out in front of potassium. That changes it to 2, but it also changes the OHs and brings that up to 2. And that's essentially balanced then. That's the only thing we need to do. We don't need to go on anymore. So the correct answer here should be 3, at least to the pole. There's 3 different species here that all have a coefficient of 1. You can vote more than once if you want to change your answer at this point. So there should be 3 species here that are all 1s. We don't write the 1s, they're sort of implied, but potassium sulfate, barium hydroxide, and barium sulfate all have those 1 coefficients out in front. Poll closed. All right. Does that make sense? Any questions on those? These are pretty straightforward ones. We're going to start here, and don't worry, Ashley, we'll get more complicated for sure. So we're comfortable with these ones? Let's go on and try this one. Calcium reacts with oxygen gas in a combination reaction. Write and balance the reaction. Yeah, I think you guys might have put 2 down because that was the coefficient that we actually wrote here, but I guess the poll question was about how many of these coefficients were a 1. Maybe. All right, so let's do this. Calcium reacts with oxygen gas in a combination reaction. So write out that reaction and then balance it. Hopefully you can get it back, Malamuha. Sometimes watching on your phone is a bit tricky. All right, so let's work on this. Calcium reacts with oxygen in a combination reaction. So I put a poll up. What's the coefficient that appears in front of calcium in the final balanced reaction? Okay, so spend 2 minutes or so working on this, and then we'll try to solve it. Enter your answer to the poll in the chat when you get there. You asked for harder problems. So yeah, the struggle's real. All right, so let's go over how to set this up. Calcium reacts with, that terminology right there means I'm going to add a plus sign. Calcium means it's just the element Ca. So calcium reacts with Ca plus oxygen gas, O. But remember, oxygen is one of these special 7 we learned about in class that come as diatomics. So, all oxygen that occurs in its natural elemental form is O2, at least for the intents and purposes of this class. There's some exceptions to that, but in this class, every time you see oxygen gas, that's O2. And it's a combination reaction, which we learned last time means they're both coming together to form one thing. So I need to write a compound that consists of calcium and oxygen. And now I must fill in the subscripts here for what ratio those two elements combine in. Okay, and for that, remember we worried about the charges above each ion. Calcium wants to be +2, oxygen wants to be -2. So when those two numbers are the same, then this is just a 1-to-1 ratio. Okay, so really, I'm fine just writing CaO because that encapsulates that 1-to-1 ratio. Okay, so now the reaction is at least set up. I'm going to skip, writing out and keeping track of Ca's and O's on each side here, and just realize that I have 2 oxygens on the left, so I'll add a 2 out in front of calcium oxide on the right. And now the oxygens are balanced. But looking at calcium, I have 1 on the left, 2 on the right, so I need a 2 in front of calcium. Okay, so this reaction is pretty straightforward to balance once you set it up correctly, but that's usually the hardest part, especially in these word problems where I'm just writing out all these elements and molecules and compounds. You need to be able to take those words and come up with the right formula, but that's really what chapters 5 and 6 were all about. Okay, so the coefficient in front of calcium there was in fact 2. J9 is up to 2 points. Crushing, absolutely crushing. Okay, any questions on that? Or other questions in general of anything we've covered in class, or, chemistry questions in general. The diatomics. Right, the diatomics are oxygen, hydrogen, fluorine, iodine, bromine, nitrogen, what else? 3, 4, 5, so that should be all of them. So these, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, these are the 7 elements that you have to memorize, always come as diatomics. So we only include the subscript for the diatomic when setting up the equation, not for the reaction. You only include this 2 right here for oxygen when it's by itself. Over here, I don't include it because this formula, the number that goes here as the subscript, depends on what it's combining with. And we use the crossover rule for that. So you don't automatically write a 2 over here for oxygen. It doesn't necessarily have to be atomic then. When it's combining with calcium, it's going to combine according to how the charges of each of those ions, calcium and oxide, how they're attracted. +2 and -2, that's a 1-to-1 ratio. Okay, but when oxygen's by itself, I have to write that subscript. Okay, so hopefully that's answering your questions, J9. Yeah, HNO in the halogens. Are the diatomics the only ones we are supposed to know? Like those will be the only surprise numbers. Others will just be stated. So when it comes to elements, and if I just say calcium, it's just calcium 1, okay? Or gold. No, if it's just an element name, it's always a 1, except for these 7 cases, it's a 2. But that doesn't mean I don't expect you to know the formula for calcium oxide, because that goes back to the previous chapter. You look at the periodic table and you determine the charge on calcium is +2, and oxygen wants to be -2. When those charges are equal, then the species come in a 1-to-1 ratio, so it's CaO. Okay, in the same way, if I told you it was sodium oxide that was made, I would expect you to know that's sodium Na, oxide O, but the 2- on oxygen crosses over and the formula needs to be Na2O. Okay, so Ashley, I mean, as far as memorization, you need to memorize these 7 elements come as diatomics, but you need to have learned by now, or need to learn, that these naming rules and the crossover rule for coming up with formulas like sodium oxide or calcium oxide, okay, or diphosphorus pentoxide, right? All these are the naming rules we learned last chapter, right? So go back and review if you haven't adequately learned those. I'm going to expect you to know how to take those words and turn them into these formulas. Okay, so let's try this first one. Complete and balance the following single replacement reaction. So I'll give you 2 minutes to work on this yourself, and then we'll go over it together. Okay, for single replacement, the first thing you need to do is check the activity series. So good on you guys for actually remembering that, or lying to me and telling me you remembered it. But either way, good job, convincing. Um, you need to check the activity series and make sure that zinc comes before lead, meaning it's more reactive than lead. Okay, so that activity series will be provided, but zinc appears before lead, so it will replace lead and take its spot. Now you do need to check the formula here. We know zinc is 2 plus, right? It's one of those special ones that always has the same charge and it's 2 plus. That's why we have the 2 down here, okay? Because the nitrate is a -1 charge, and so the 2 plus from zinc crosses over to give us that 2. It's not there because it appeared that way on the left, right? It appears there on the left because lead had a 2 plus charge. It doesn't mean it's always going to be 2 on the right. Okay, so just be careful about that. So writing this out, I mean, there's nothing left really here to balance. Everything's 1 to 1 already, so as long as we filled that in correctly, there it is. Okay, the second one here, cadmium plus iron nitrate. First things first, let's look for the activity series. Cadmium comes after iron, so I don't even have to go any further and worry about what's going to happen here. I'm just going to write Nr because no reaction happens. Okay, because cadmium comes after iron in the activity series. All right, so hopefully that makes sense as soon as you see single replacement. You should also be able to identify these as single replacement because it's an element plus this compound. Okay. One metal replacing another metal. All right, let's try this. I think this is the last one I have at least prepared ahead of time for balancing reactions. We can do more. Let's try to balance this reaction. Vote for 2. We'll give you another minute or so to work on this. Remember, you can't win bonus points if you don't vote. One's a little complicated. How you guys doing? Where are you struggling? You have the right numbers. Here to start. Should be 5 hydrogens to start. On the left, 1 manganese, 1 phosphate, oxygens. On the right, should start with 3 manganese, 2 phosphates, 1 oxygen. Oh, got away from me. 1 oxygen on the right. So this one's a little tricky because I'm treating oxygen by itself. Okay, I'm treating phosphate, which contains oxygen, as a separate entity because phosphate appears on each side. Okay, there's OH on the left, but I can't, or I don't like to treat it as an OH unit because there's not an OH really on the right. Your head's hurting? Okay, so this is the way I'm going to at least set it up. You can set it up different ways in terms of if you want to treat the oxygens all as atoms and the phosphorus is all as atoms, that should work. It just sort of overcomplicates it for me. So I'm going to treat these polyatomics as a group. There's a single PO4 unit on the left. There's 2 of those PO4 units on the right. There's 1 manganese on the left, 3 manganese on the right. Okay, there's 5 hydrogens on the left, 3 from this phosphoric acid, 2 from this compound for a total of 5. Okay, and then the oxygens, the non-phosphate oxygens, I should say, 2 on the left, 1 on the right. Okay, so I'm going to start with the more complicated species here. I'm going to work on balancing that first. Okay, which means I'm going to try to balance those phosphate units first. Which means I have to add a 2 on the left here. So I'm adding a 2 in front of the phosphoric acid here. Okay, doing so's added the additional phosphate unit I needed, so now those are at 2. But I've also affected these hydrogens. Okay, I have 2 times 3 now for 6 hydrogens from this phosphoric, but I still have the 2 hydrogens from this other compound. So I've changed my hydrogens now on the left to 8. Okay, let's go on. I'm going to attack the manganese next. You could attack the hydrogens. I tend to leave sort of the hydrogens at the end because they appear several different places and it can get complicated. So I'll usually start with a polyatomic like phosphate, then I'll move on to some metal, that only appears once on each side and try to balance that. So I'm going to try to balance the manganese by bringing that up to 3 by adding this coefficient out here. So that's balanced my manganese. Of course, it's affected my oxygens. I now have 6 on the left, my non-phosphate oxygens. 2 OH groups here, but there's 3 of those whole molecules. So 3 times 2 oxygens per molecule is a total of 6 oxygens. And now my hydrogens, there's 6 from this manganese hydroxide, plus there's 6 from this phosphoric acid. So now that's at 12. So now my manganese and my phosphates are balanced. Hydrogens are severely imbalanced. Oxygens, I need to balance as well. So let's treat oxygens. I need to get the oxygens on the right up to 6. So I'm going to add a 6 in front of water on the right. That has balanced my oxygens. It also means that now my hydrogens have gone up to 12 on the right, which is convenient because that's what I needed. Okay, so this represents the balanced reactions. Okay, the correct answer for the poll here was a 2 in front of that H3PO4.